Hi, my name is Genevieve Hall. To start this presentation, I'm going to ask you to close your eyes. Yes, please close your eyes. Now that your eyes are closed, I'd like you to think about moving your fingers, deliberately moving your fingers. And now I'd like you to think about deliberately moving your toes. Just think about it. When you make that mental connection where your brain tells your fingers to move, is a neurological connection between your brain and your fingers. And sometimes as you get older, those connections can sever, especially when there's been an accident. And there's nothing that I can think of worse than not having control of your body. And that is the fate of millions of both Americans and people worldwide as they get older. But there is a way to combat that. There is a way to help people who are in that situation, and it's called brain-computer interface technology. And that's what we're going to talk about today. Thank you for your participation and welcome to my presentation. Again, my name is Genevieve Hall, and this is a presentation about how brain-computer interfaces can improve the quality of life experienced by the elderly. So why should we choose to pay attention to brain-computer interfaces? And I would say because the use of brain-computer interface technology is important to society at large, but is especially important for the elderly population. It can be expected that by 2035, the number of older households with a disability will increase by 76% to reach 31.2 million people. And these kind of disabilities affect mobility, self-care, and household activities. When elderly people can't attain certain life goals in their daily experience, it becomes very hard for them to live alone. And it becomes very, very self-isolating when they can't meet their needs on their own. I believe that the brain-computer interface technology can help mind the gap and build the gap between what people can do and what people can't. So what is brain-computer interface technology and what is its potential applications? Well, a brain-computer interface is a computer-based system that records brain signals, analyzes them, and translates them into commands. Brain-computer interfaces allow users to complete daily tasks by using brain signals rather than muscles. This technology is still being researched and developed, and there are currently no commercial applications, but the research is very promising. There are researchers who have had their subjects be able to move the mouse on a computer screen with just their mind. They have been able to type out words using their mind, and they have been able, with the help of other applications such as EKGs and visual response locators, to be able to combine the brain-computer interface technology with other technologies to actually move things with people's minds. And this can have a lot of great applications, such as wheelchairs that can be used with the mind, such as exoskeletons for people who have suffered severe disabilities and can no longer walk or have use over their arms or their legs. And then there's simple applications that you could foresee being used in commercial applications, such as being able to change a TV channel, perhaps turn on a video camera to talk to one's loved ones, or even as simple as typing out messages through the mind. One can see how these applications could readily be used by the elderly population to really help their daily living needs be achieved in a way that is natural and intuitive rather than difficult and depressing. So how do computer interfaces work and how can they currently improve the quality of life of the elderly? BCI technologies come in many different forms, but generally speaking, they can be divided into two categories: invasive and non-invasive. The differentiation depends on whether the sensors used to measure brain activity are penetrating the skin or not. Invasive BCIs use small grids of electrodes implanted directly into the motor cortex of the brain and related areas to measure brain responses, interpret the response, and control the secondary device. Non-invasive BCIs require sensors to be placed on the scalp to measure the electrical potential produced by the brain, best known as the EEG, or the magnetic field. Currently, we see many more researchers using non-invasive BCI technologies, partly because it's easier. We do not see that many invasive BCI technology research, but we have seen some big ones. Elon Musk and his Neuralink project is probably the most famous. In the long run, invasive BCIs are most promising because they can more readily read the neurons and the information that they are sending out through the brain signal. With the non-invasive BCI systems, it's harder to read those controls that are coming from the brain cortex. So when are we going to see BCI technology readily available? In the case of BCI, acceptance will be a big barrier to universal adoption of BCI technology because in many ways it seems scary and a bit like something out of a sci-fi novel. To have universal application, especially in the elderly population, there's going to need to be a lot of education in regards to exactly what it is and how it can help them personally. Because if you can't show an individual how the technology is going to actually help them, they're not going to adopt it, especially in the case of BCI, because it is a little bit scary. The big takeaway for both this class and for BCI technology itself is that the more natural and intuitive a process design is, the more usable it is by a population at large, but especially for the elderly. If we can eliminate the interface that we're using to accomplish activities of daily life and just use the mind, that would be the most natural and intuitive process, and I think would help the elderly readily adopt the technology because it would be so easy and would make their life so much better.